This oil leak's been going on for over 50 days, and there doesn't seem to be a good solution in sight yet, as oil is still spewing into the sea in large volumes, and that is a disastrous situation for the whole environment out there. This idea is very simple, and I just can't believe that nobody's come up with it yet. This simply involves two parts. It's basically lowering a dome on top of the oil leak and capturing that oil. And I can explain here how I do this in my example, which is different than the dome that BP had tried to lower early on in the first week or two after the leak. My idea here just consists of two parts, basically. One is a dome, and the other is a riser pipe that rises up to the sea surface to be collected and dumped into a ship. And this idea relies solely on the different specific gravities of water and oil. You've heard people say water and oil don't mix, and that's right. We take advantage of that here. Water and oil does not mix. Oil rises to the surface if it's allowed to do so. What I'm doing here with this little tube, black tube that you see, all I'm doing is I'm introducing oil to simulate the leak coming out of the ground. This leak is captured by a dome put on top of it. Now this dome would be of sizable dimension, perhaps 20 feet by 30 feet or something like that. And the oil would simply be captured and go up a riser pipe. Now the dome, I wanted to note, is completely open to the seawater, and that is important. It's completely open, it's not sealed on the seafloor or anything like that. A significant difference between my dome and the dome that BP attempted to use at the early part of this leak is that they installed this dome and they put in at the top a small pipe. I believe the diameter was like 12 inches. And their idea was to suck the oil out of the dome. That means that they're dealing with a closed system, and because of the smaller pipe, crystals formed, but buoyancy occurred because there was more oil coming in that would be jettisoned out anyway, or being sucked out. In my case, the pipe on the top of the dome is large, meaning around 36-inch diameter, and it would extend up about 30 feet. This would allow the oil to simply rise up and outside of the dome. This should happen quite naturally because the oil is lighter than water. It has a lower specific gravity, and that's what's going to happen. Then, to complement that, I lower a pipe of larger diameter, approximately 48 inches, and only because it's a more standard size of piping than going perhaps to a larger pipe, although I guess there is no limitation to that. So you lower a 48-inch pipe on top of the 36-inch pipe means that there's an opening left between the two pipes. I refer to that as an annulus opening. That's an important phenomenon because in my situation, I don't use a pressurized system whatsoever. It's completely open to the seawater. Both the dome is open and the riser pipe is open. And that has a few very important advantages in that, first of all, one can be lowered independent of the other, and no work needs to be done at the bottom of the sea. All the work is done at the top. When you lower this pipe on top, that's a second step. You lower this pipe on top, and the oil is simply allowed to rise to the surface. As the oil rises to the surface, and I have my pipe extending beyond the sea surface, an oil column will be generated because you're not taking oil out at that point, up to a certain height. Now, I figure in real life I would have a T similar to this, but a 48-inch T, fitted on the pipe at a level approximately 30 feet above sea level. What would happen is an oil column gets formed just like this, and the oil rises and is simply discharged onto a waiting ship, just as I do here, except in my case it's just a storage tank. I went as far as to file a patent as of Friday a week ago, and also I got this prototype manufactured here to demonstrate my system.